Welcome to aminacademy.com in fluid mechanics regarding viscous resistance of journal bearings. Look at this figure. Here it is a journal bearing. A shaft is rotated inside the journal bearing. Consider a shaft of diameter d rotating in a journal bearing. The clearance between the shaft and journal bearing is filled with viscous oil. The oil film in contact with the shaft rotates at the same speed as that of the shaft, while the oil film in contact with journal bearing is stationary. Thus, the viscous resistance will be offered by the oil to the rotating shaft, that is, due to oil film, the frictional resistance is reduced and easy to rotate the shaft. So let N equal speed of the shaft in RPM. Revolution per minute RPM. Let T equal thickness of the oil film. L is length of oil film. Means length of journals. Angular speed of the shaft equal omega is 2 pi n by 60 radian per second. Tangential speed of the shaft is nothing but omega r, which means omega into diameter by 2. Therefore, we can write V equal 2 pi n by 60 into d by 2, which is pi dn 2 and 2 cut pi dn by 60. The shear stress in the oil is given by tau equal mu du by dy. That means at the thickness of the oil film is very small, the velocity distribution in the oil film can be assumed linear. Therefore, we can write velocity distribution is linear. Therefore, du by dy equal v minus 0 over t. V means final velocity minus initial velocity 0 over thickness. That is v by t. That is v is already pi dn by 60 t. Therefore, we can write tau shear stress is mu pi dn by 60 t. Therefore, shear force or viscous resistance. Therefore, you can write shear force or viscous resistance shear force or viscous resistance we can write to into area of the surface of the shaft. Area of the surface of the shaft. So that is equal mu pi dn by 60t into pi dl, which we can write mu pi square d square nl over 60t. Next one, torque required to overcome, because this shear stress must be overcome by torque supplied by the shaft from external forces. Torque required to overcome look at this figure for this. Here the torque is given by rotating the shaft from the external power. So this oil film have the shear resistance to overcome the viscous resistance. Overcome the viscous resistance, that is T equal viscous resistance into D by 2. So let us have some more space for here. Then which is equal, therefore T equal mu pi square d square nl over 60t into d by 2. Further it is mu pi square d cube nl over 120t. Therefore power absorbed in overcoming the viscous resistance is P equal 2 pi nt by 60. Substitute t value we have, therefore P equal 2 pi n into t value is mu pi square d cube nl over 120t. So therefore P equal mu pi cube d cube n squared L over 60 into 60 t. So this is the power required to overcome the viscous force in the journal bearing. Now let us do an example problem. A shaft having diameter 50 mm rotate centrally in a journal bearing having diameter of 50.25 mm and length 120 mm. The annular space between the shaft and bearing is filled with oil of viscosity 0.95 poise. Determine the power absorbed in the bearing when the shaft of rotation is 550 rpm. Now the given things we'll write. Diameter of the shaft equal 50 mm, which is equal 0.05 meter. We converted in meter. Next, D1, that is dia of bearing. Dia of bearing is 50.25 mm, which is equal 0.05025 meter. Length of bearing, length is 120 mm, which is equal 0.12 meter. Mu, viscosity of the oil is 0.95 poise, which is equal 0.95 over 10 Newton second per meter square. We can write this value also, that is equal 0.095 Newton second per meter square. Thickness of the oil film is D1 minus D over 2, which is 0.05025 minus 0.050 over 2 equal 0.000125 meter. Next one, the velocity. Now we'll do first velocity, tangential velocity, tangential speed or velocity, tangential speed of shaft equal V by dn by 60, which is equal pi d is 0.05, n is 550 rpm over 60, which gives approximate 1.44 meter per second. Now next is shear stress. Tau equal mu du by dy, which is further equal mu v by t, because it's a tangential, so du equal to, we can write v by t. So having 0.095, that is mu, into v is 1.44 over thickness is 0.000125, which is 10,094.4 Newton per meter square. Then force, shear force. shear force equal shear stress into area, which is equal shear stress is 1094.4 into area is pi dl, pi dl, which is equal 1094.4 to pi, diameter is 0.05, L is 0.120, which is 20.62 Newton shear force. Now resistance torque, resistive torque, resistance torque is T equal F into D by 2, which is equal force is shear force is 20.62 into diameter 0.05 over 2, which is 0.515 Newton meter. Therefore, power required to overcome this resistive torque is 2 pi nt by 60. So which is 2 pi n equal 550, torque is 0.515 over 60. Therefore, power P equal 29.65 watts. You have done. Please subscribe our YouTube channel.